Hi guys, and welcome to another video. This video is about Passthrough and IOMMU groups. We'll be talking about what IOMMU is, the PCI Express architecture, and how to deal with problematic IOMMU groups. Right, so let's talk a little bit about IOMMU groups and then how to break them up if necessary. So, what is IOMMU and why is it important to us on Raiders? Well, to understand this, we need to be aware of what capabilities that our server must have in order to support the running of a VM. To set up a VM, our CPU must support Intel VTX or the AMD equivalent AMD-V. This functionality is known as HVM. Having this feature allows us to set up simple VMs using things such as VNC emulated graphics and being able to assign the USB devices attached to the host. Now, for many people, this functionality is fine and that's all they're going to need. But if you want to set up a more advanced VM and being able to pass through a piece of hardware for that VM's exclusive use, for example so the VM can use a dedicated GPU, or to be able to use a USB controller so we can hot swap USB devices in and out just as we would as if it was a bare metal computer. Well, to be able to do this, then our server needs to have an additional capability. Our server must also support Intel VTD or AMD VI, and this is commonly known as IOMMU. So, how do we know if our server supports these features? Well, the easiest way to see if your system already has this feature and that it's been enabled, because sometimes this feature isn't enabled by default, it's to look on the Unraid Web UI and then in the top right hand corner click on the button saying Info. Okay, so here we can see the system information. We've got information here like the motherboard make and type, as well as the CPU type as well. And then under the CPU type, that's where we can see whether HVM is enabled and whether IOMMU is enabled. So again, if we have HVM enabled, we can make simple VMs without pass-through, but if we have IOMMU enabled as well, then we can do pass-through to the VM. Now, even if when you check here you find your IOMMU isn't enabled, that might not be because your CPU and motherboard don't support it. Often you actually have to go into the BIOS of the motherboard and enable that function yourself. Now, most modern Intel and AMD chips support IOMMU, so if you look up the info on your CPU, then you can see if this is a feature of your CPU or not. Now, if your CPU supports VTD or AMD VI, then that's not the end of the story. For this to work, support is needed not only by the CPU, but also by the motherboard chipset and the BIOS or firmware of the motherboard. The BIOS revision of your motherboard can actually affect IOMMU support. Now, sometimes a newer BIOS revision for a motherboard can actually improve IOMMU support. This is especially true of the AMD Ryzen motherboards. However, I've also known of a BIOS update actually breaking the IOMMU support. Now, on one of my first Unraid servers, I was running a Xeon 1230 V2 on a Micro ATX ASRock board with socket 1155. But I can't remember the exact model of the motherboard. But what I found is when I got the motherboard, I actually had to downgrade the BIOS back about, I think it was 3 versions older than the current, in order to get my IOMMU working. So obviously somewhere down the road an update had actually broken the IOMMU support. Now I think this is pretty rare, especially nowadays. That board was quite a few years old, but I think it's still worth keeping in mind. And also something else to keep in mind is the actual settings in the motherboard itself. On my Gigabyte AMD Ryzen motherboard, that actually had 3 different settings for IOMMU. This board had 3 settings. There was auto, enabled and disabled. Now you'd think that auto and enabled would be the same, but having IOMMU set to auto, you get far worse grouping than you do when it's set to enabled. So on Ryzen motherboards, if you see this setting, make sure you have yours set to enabled and not to auto. Anyway, I've been talking about IOMMU, but I haven't really said exactly what it is and how it relates to running a virtual machine. Well, IOMMU is an abbreviation for I/O Memory Management Unit. And so what IOMMU lets us do is to remap devices as we see fit, because each piece of hardware has a physical address, but the physical address used by a real piece of hardware, for example a graphics card, doesn't correlate to the VM's physical address. So this is a problem because if the guest VM tried to use the device performing direct memory access, then it would access the wrong memory address because they're not the same. So basically what IOMMU does is it translates the device's physical address on the host to the physical address on the VM, and also it handles interrupt remapping as well. And it does all of this transparently. So the guest VM just thinks the device is physically connected to itself. It's not really aware of the host at all. You can kind of compare it to like when you use a phone divert system from say a landline number to a cell phone. As far as the caller is concerned, they've dialed the landline. The caller doesn't know the cell phone's number as everything is done transparently, and the caller doesn't even know that you're using a cell phone to answer the call. So IOMMU is similar in the fact that it's just mapping one number address to another. And whilst IOMMU is translating the host device to the VM, the host during this time is unable to use the device, and this is what we mean by being passed through. Now, like I said, all of this is done transparently, and when the VM is first started, it then configures the IOMMU, and then from then on, everything is automatic. Now, this initial configuration is when we can have problems with our IOMMU groupings, and we may get an error that looks like this, saying that our IOMMU group is not viable. So let's look at our IOMMU, and to do that go to Tools, and then System Devices, then here we can see our IOMMU groups. And the error was telling me I had a problem with my group 19, and what I was actually trying to pass through was this motherboard USB controller here. So let's take a closer look at IOMMU group 19. So here we can see the problem. The USB controller isn't isolated on its own. If it was, then it would have its own IOMMU group and there wouldn't be a problem. So you may be wondering, why are just not all devices in their own IOMMU group? Well, in an ideal world, that would be great. And actually some hardware is better than others when it comes to IOMMU. However, to understand why devices are not separated, we need to talk about the PCIe architecture. And this architecture is hierarchical. At the very top, we have the interface between the CPU and the PCIe buses, and this is called the root complex. From here, we have PCIe root ports, which can go to one of three different things, each of which having its own hierarchy. It can go to a device endpoint straight away, or it can go into a switch or a bridge. Switches just allow us to have more devices connected to a single root port. I guess you can kind of think of it a bit like a USB hub. It has one upstream port and multiple downstream ports. And bridges, they provide an interface to other buses, such as PCI or PCIX. So all of our devices at the bottom are endpoints, completing the transactions on the bus, so therefore only having a single upstream port. Now, the PCIe specification allows for a PCIe downstream port to reroute from one downstream device to another. This is called peer-to-peer transactions, and because of this data path optimization, these devices can talk to each other, therefore skipping the IOMMU translation. So obviously, this isn't good if we need isolated devices. But to combat this, we have something called PCIe ACS, and ACS stands for Access Control Services. And what ACS does is to check if these redirects are possible, and then giving us the ability to disable them. So, as you can see, ACS is very important for us to have fully isolated devices. Now, remember when I said some hardware is better than others? Well, on some hardware, often the interconnects often lack proper ACS support. And that's why my USB controller is in group 19 with other devices. Because of this lack of proper ACS support, the computer has to take the assumption redirection is possible, so it puts the devices into one group. So you may have heard of the ACS override patch. This is a kernel patch which allows us to use command line options to artificially expose isolation capabilities of the devices. However, we can't be sure that the devices are truly isolated, and it is possible we can have misdirected DMA causing stability and security problems. However, we may also find that the devices work fine, and in fact they are isolated, so it's always a bit of a gamble. As well, what works fine using the patch on one machine may not work at all on another, so we'll come back to the 3 different ways of using the ACS override patch shortly. But first, let's look at other ways of tackling the problem of passing through a device in an IOMMU group with other devices. Well, the first thing to do is, if you can, move the device to a different PCI slot. This can sometimes put a device in another IOMMU group where we'll not have this problem. Well, for me here with this example of my USB controller, well, it's an onboard motherboard USB controller, so obviously I can't move it. So let's take a close look at the error message again. Now the error message is telling us that group 19 isn't viable, and it tells us to check all of the devices are bound to their VFIO bus driver. So what does that error mean, and just what are the VFIO bus drivers? Well, it's telling us that to use any of the devices in this IOMMU group, they must all be bound to a VFIO driver. Now I say all devices, this excludes any interconnects such as PCI bridges, etc. So for me in group 19, I would exclude the host bridge and the PCI bridge. Okay, so what does it mean by binding the devices to a VFIO driver? Well, the driver it's talking about is the VFIO-PCI driver, and we bind the devices to this driver in the syslinux configuration file. So let's do that now. So on the Unraid Web UI on the main tab, let's go down to where it says Flash, and here's our syslinux configuration file. Now we need to look at the part where it says menu default, because this is the part of the syslinux configuration file that Unraid will load by default when it boots. Now we need to look for this line here, starting with append. Then on the same line we want to add VFIO-PCI.IDs equals, and then we need to look for the ID numbers of each device, and that's the numbers at the beginning inside the brackets. And so the first one for me is 1022-145A, and then we want to put a comma for the next device, and for me that's 1022-1456, and then put another comma for the last device. And now this is my USB controller, and that's 1022-145C, and we can click on to apply. Now if you're using the latest RC version of Unraid, there's a nice thing we can do with the syslinux configuration file, is we can toggle here over onto advanced view, and it just splits things up a bit nicer. Now we can see here, that's the line that we just edited. Anyway, so once we've done that, we need to reboot the server. Now on boot, Unraid will bind these devices to the driver, and these devices will now be isolated from the host. So now the server's restarted. Let's quickly just have a look at the IOMMU groups. Now they haven't changed at all. Group 19 is still the same, and just one thing to point out here, I've got these exact same devices actually in group 6 as well. And that's not because we've bound them to the VFIO driver, that's just how my IOMMU groups were originally. But I just wanted to show you this because when we look at the VM manager in a moment, we'll see these devices listed twice, and that's why. So now let's just go across to the VMs tab. So let's look inside this template. And if we scroll down to the bottom, under other PCI devices, we can see all of the devices that we bound to the VFIO driver earlier on. Now as you can see, I've only checked the USB devices here, because we don't actually need to pass through all of the devices that are in the IOMMU group. We only have to have them bound to the VFIO driver. So now let's go back and then start up the VM and see if we get the error now. And no, the VM's starting up absolutely fine with the USB controller passed through and working. But while we've got this VM running, let's just try a little experiment. Let's edit my Fedora template here and add one of the other devices. Let's add the platform security processor. And then let's try and start up the VM and see what happens. But the VM won't start and we get this error, telling us that the device is in use with the domain that we just started here. The device isn't actually passed through to that domain, but it's unavailable because of the other device in group 19, the USB controller, that's passed through to the macOS VM. Okay, so this is my preferred way to pass through a device which shares its IOMMU group with other devices. But we can't always do this if the other devices are needed by the host. So that's when we'd use the ACS override patch. So let's go across to my other server. Let's look at the devices here. Now the IOMMU grouping isn't too bad on this server, but I'd really like to better pass through this capture card here to a Windows VM. But if I try, I'm just going to get the same error as before, telling me that the IOMMU group isn't viable. And there's 3 Ethernet controllers in this IOMMU group, so I can't bind these to a VFIO driver, else I'm going to lose the use of them in Unraid, and then my server's just not going to work. So we need to use the ACS override patch. Now the easiest way to do this in Unraid is to go to Settings, and then go to VM Manager, and then toggle from Basic View to Advanced View, and then at the bottom here, enable the ACS override, and click Apply. Now we do have to reboot the server for these changes to take effect, but first, let's have a look at what this has done to the SysLinux configuration file, and what commands it's put in. So let's click onto Flash. This here is the command that's been put into the SysLinux configuration file for us. And just to make this easier to see, I'm going to toggle across to the advanced view for the SysLinux configuration file. And we can see that command is PCIe _ACS _override equals downstream. And the equals downstream part here overrides the missing ACS support for all downstream ports. And usually this is enough to break up the IOMMU group. So let's restart the server and see if that's done the trick. Okay, so let's look at our IOMMU groups now. Well, unfortunately nothing's changed. So what can we do now? Well, let's go back to the main page and go to our flash drive. And we're going to edit the SysLinux configuration again. Now this time we're going to use PCIe _ACS _override equals downstream and then comma multifunction. And this overrides the missing ACS support for all multifunction devices. So let's try that and reboot the server. Okay, so let's look at our IOMMU groups again. Okay, and now we can see that everything's pretty much split up. And here's my capture card in group 28. But please remember, this isn't my proper IOMMU. These devices may not actually be isolated. So now I can go to my VMs and pass through the capture card. And the VM's starting fine. So it looks like everything's split up here. But I personally don't like to use the multifunction option unless I have to. So let me show you a third way. Okay, so I've set the server back to how it was with its natural IOMMU groups. And here's my problem group, group 15. Now again I'm going to use the PCIe ACS override patch, but this time I'm going to use a different command. I'm going to use PCIe _ACS _override equals and then ID : and I'm going to specify the first bridge that we see here. And then hopefully everything underneath will be split into individual IOMMU groups. So let's copy the bridge's ID number and paste it in after the colon. Now let's copy this whole line and then paste it into the SysLinux configuration file. So let's go to the main tab and then flash and paste it in here. And then click apply, then let's go and restart the server. Okay, so the server's rebooted, so now let's go and check out our IOMMU. And we can see now that the group's been broken up. And here's my capture card along with a bridge, which is absolutely fine. So this will now pass through fine. So let's go to VMs and check the Windows VM. This is checked to pass through. So let's start up the VM and check the capture card works. And there's a screenshot of the capture card working. Okay, so there's a few different solutions there for passing through problematic devices that are stuck in IOMMU groups. But again, I just want to say, only use the ACS override patch if you really need to. Don't just use it by default. So guys, that's the end of another video, and thanks for watching. I hope you found it useful and you now know a little bit more about PCIe Architecture, IOMMU and Passthrough. And just before I go, I want to give a huge thanks to all of my patrons and supporters. You guys make these videos possible. And as always guys, if you like the video, then please just take a moment to give it a thumbs up. And if you haven't subscribed, then please subscribe for more videos. Anyway guys, it's time for me to go, so whatever you're up to for the rest of the day, I hope it's good and I'll catch you in the next video.